If you studied physics, you will definitely be familiar with what is going on here. Now, let us go back and see what gave rise to this figure. We have a question here that says, what is the critical angle for light traveling from water to air? The refractive index of water equals 4/3. I want to start from the basics in this question by explaining some basic concepts, right? So let's take it one after the other. We have two medium, water and air. According to the question, light ray is traveling from water to air. It means this is the original medium we are considering for the incident ray, while air is the second medium for the refracted ray. Let's call this the normal to the surface of the two media. We can say that the incident ray travels from water in this direction, making an angle C with the normal. This incident angle is what we call the critical angle C. What is critical angle? We are going to come to that in a bit. However, the incident ray travel making an angle of incidence to the normal until it gets to the point of separation of the two surfaces. At this point, the light ray is refracted in the second medium, air. Remember that water is denser than air. Because of that, the refraction is going to be away from the normal. In this case, the refraction is going to be at 90 degrees to the normal. Why is it 90 degrees? Let us go back in time looking at refraction. If the incident ray was traveling somewhere in between this incident ray and this normal, if the incident ray was traveling somewhere here, when it gets to this point, it will be refracted away from the normal in this direction. If you increase the incident angle further to something like this, the refracted ray increases further away from the normal. If you keep increasing the incident ray, it gets to an angle known as the critical angle, for which the refracted ray makes 90 degrees to the normal. It is this angle of incidence that is called the critical angle, and that is what the question is asking us to find. Now we know that the incident ray in the denser medium, water, is at critical angle. Definitely the refracted ray in air will be at 90 degrees. So this angle is 90 degrees. That is the basics. Now let's continue. What is refractive index? We define refractive index as the ratio of the sine of the angle of incidence to the sine of the angle of refraction, where this symbol here is the symbol for refractive index. So this is the general formula for refractive index in terms of the angle of incidence and angle of refraction, where refractive index is equal to sine I, angle of incidence, divided by sine R, angle of refraction. And the refractive index is always defined as that of the medium for which refraction is taking place, which is the second medium. In this case, that medium is air, because that is where the refraction is taking place. So we can say in terms of air that the refractive index of air, I put in A here to represent refractive index of air, because that is the medium refraction is taking place. The refractive index of air is equal to sine C, because the incidence in this case is critical angle, sine C, all over sine 90, because the refractive the angle of refraction in this case is 90 degrees, sine 90. You agree with me that if you put in sine 90 in your calculator, you're going to get 1. Sine 90 degrees is 1. So the refractive index of the light ray in air is sine C all over 1. But we are given the refractive index of water and not the refractive index of air. Of course, we are always given the refractive index of the denser medium, right? But something to take note of something to take note is the reversibility, the principle of the reversibility of light. The path of light is reversible. It means if the light travels like this, as is shown here now, if you reverse the path, it is also going to travel like this. So that is the principle of the reversibility of light. What it means is that by reversibility of light, we can take the inverse of this refractive index to get that of water. It means if the incident ray was in water, it was in air, it is going to be refracted like this in water. So, because of that principle, if we take the inverse of the refractive index of air, we would have obtained the refractive index of water. Since that is what is given, let us do that. So we cannot just take the inverse of the refractive index of air, we have to take the inverse of both sides of the equation. So if we do that, we take the inverse of the refractive index of air and take the inverse of this right hand side, that gives us 1 over sine c. Of course, the inverse of the refractive index of air is the refractive index of water. So this can be replaced by the refractive index of water being equal to 1 over sine c. From here, we can solve for the angle C, which is the critical angle. The refractive index of water is given as 4 over 3. Putting it into the formula, we have 4 over 3 equals 1 over sine c. To obtain C, we need to make sine C subject of the formula. So sine C will definitely be the inverse of 4 over 3, and that is 3 over 4. 3 over 4 is 0.75. To obtain C, we take the sine inverse of the right-hand side, right? Or arc sine 0.75. So C will be the sine inverse of 0.75. And if you put this into your calculator, you are going to get 48.6 degrees. It means the critical angle of water for which the critical angle for which the refractive um, the critical angle of water for which the refractive index is 4 over 3 is 48.6 degrees. And this is like a constant value for light traveling from water to air. If you understood this, then try this simple one here. What is the critical angle for light traveling from glass to air, given that the refractive index of glass is 3 over 2? Please put your answer in the comment section and I'll be there waiting for you. Once again, thank you for watching this video and hope to see you in our next video.